Now, in this class, I want to be explaining how we can use long division to carry out division in number basis. So, apart from that method of first converting to base 10 before converting back, before dividing and converting back to the required base, that's not professional enough. So, let's look at it. But first, let's revise what we did in primary school. Let's say you want to divide 216 by 3 in base 10. Normally, that primary school division is base 10. 3 times 1, we need 3 times table. If you are dividing by 2, you need 2 times table. If you are dividing by 5, you need 5 times table. Now we are dividing by 3, we need 3 times table. 3 times 1 is 3, 3 times 2, all of these are in base 10, is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5, 15, 3 times 6, 18, 3 times 7, 21, 3 times 8, 24, 3 times 9, 27, and so on. Now, we draw our long division sign. 216 divided by 3. How many 3 in 2? Impossible. We pick the 2 together. This and this, the first 2 digits. As 3 in 21, that will give us 7, because exactly we have 7 here. It goes 7 times. 3 in 21, that's 7. Write 7. 3 times 7, 21. Subtract. That give us 0, 0. Drop this. So, how many 3 in 6? Check the table. You can see that we have exactly 6. So, 3 times 2 is what gives us 6. 3 times 2, so that will be 2. That's 3 times 2 will give me 6. Subtract. So we have this. So this is the normal thing we used to do in primary school. That's anytime you are dividing by 3, you need multiplication table in 3 times table in base 10. Now, let's now apply this to number base. Let's divide in number base using long division. So we want to divide 2115 by 12 in base 7. First, both of them must be in the same base before we can divide. Let's see, 2115 base 7 divided by 12 base 7. Now, I am going to draw this 2115 divided by 12 base 7 base 7. Now, I will need, anytime I'm divided by 12, I need 12 times table. But this time around, it must be in base 7. Let's multiply. Let's do that. 12 times 1 in base 7 is 12. In any base, 12 times 1 is 12. But 12 times 2 in base 7 is still going to be 24. Let's try that. 12 times 2. What is 2 times 2? 4. 4 is not up to the base. I will write it. 2 times 1, 2. It's not up to the base. That's 24. This is still correct. That's still correct. Let's try 12 times 3. 12 times 3 in base 7. 3 times 2, 6. It's still not up to the base. Let's write it. 3 times 1, 3. So it's still not up to the base. We are writing it. That's 12 times 3 equal to 36. What of 12 times 4? Let's see what 12 times 4 will give us in base 7. 12 times 4 in base 7. 12 times 4 in base 7. Now, that is going to be 12 times 4. 4 times 2, 8. 8 is not in base 7. We have to divide by 7. Write the remainder and carry the quotient. 8 is 7 and 8. That's 1. Remainder 1. We are writing remainder 1. Carry the 1. 1 remainder 1. So 4 times 1 is 4 plus 1. That will give us 5. So that means 12 times 4 will give us 51 in base 7. So let's go again. Let's go to 12 times 5. What is 12 times 5 in base 7? 5 times 2, that's 10. 10 is not in base 10. We have to divide. That's 1 remainder 3. Divide by 7. 1 remainder 3. Put down remainder 3, carry 1. 5 times 1, 5 plus 1, 6. That will give me 63. That means 12 times 5 is equal to 63. Let's go one more time. 12 times 6 in base 7. What is 12 times 6 in base 7? 12 times 6 in base 7. 6 times 2, that's 12. 12 is now in base 5. So we have to divide by 7. How many 7 in 12? That's 1 remainder 5. Put down 5, carry 1. 6 times 1, 6 plus 1, 7. 7 is not in base 7. We have to divide by 7. How many 7 in 7? 1 remainder 0. Put down remainder 0, drop the 1. So we have 105. Let's stop here first and see whether we can still go. Let's go one more time. Let's go one more time. So, what is 12 times 7 in base 7? First, 7 is not in base 7. We have to convert. 12 times 7. What is 7 in base 7? You divide 7 by 7. That's 0. 1 remainder 0. Put down remainder 0 and drop the 1. That's 10. That means 7 in base 7 is 10. Multiply. That will give me 0 times this 0. 0 times this 0. 1 times 2, 2. 1 times 1, 1. Let's add. In base 7, 0, 2, 1. So that means 12 times 7 in base 7 is equal to 120, 120. So I think we can use this first. Let's stop here first, then apply it to what we need. Let's see if we still need to do more, we will do more. Now, how many 12 in 2? Impossible. Pick the first 2 digits. How many 12 in 21? Check your table. 12 times 1 is 12. 12 times 2 is 24, which is bigger than 27, 21 already. So that means we can only go for this. Let's go for the first one. So because this is already bigger than 21, that means 12 in 21 is only once. 12 times 1, 12. Subtract in base 7. Subtract in base 7. 1 minus 2 in base 7, impossible. Borrow from here. This remains 1. By the time you throw the 1 to this place, it becomes 7. 7 plus 1, 8. 8 minus 2, that will be 6. 1 minus 1, that's 0. This is gone. Drop this 1. How many? This will be 61. How many 12 in 61? Check your table. 12 times 1, 12. 12 times 2, 24. 12 times 3, 12 times 4. 12 times 5 is 63. So the previous one is 51. 63 is bigger than 61. So we go for the previous one, which is 4 times. So how many 12 in 51? That's 4. How many 12 in 63? That's 4 times. 12 times 4, that will give me 51. Now let us subtract. 1 minus 1, 0. 6 minus 1 in base 7. That's 1. Let's drop this 5. We have 105. How many 12 in 105? Oh, that is exactly 6 times. That is exactly 6 times. So 12 times 6, that will give me 105. Thank God. Let's subtract. That will be 0, 0, 0. So now, finally, we can conclude that 2115 divided by 7, base 7, divided by 12 base 7 is equal to 146 base 7, which is the same answer as what we got when we used the previous method. Thank you for viewing this. No matter the method you follow, you must get the same thing. So thank you for viewing this. God bless you.